Good morning, dear students. Welcome back again with the new session of Science 1, lesson number 8, Metallurgy. First of all, we should know the meaning of metallurgy. Metallurgy is that branch of science which deals with the extraction of metals. And before that, we should know about the certain properties of these metals. So, first of all, it is found under these metals are found under the earth crust and how the earth evolved that we are going to discuss. That is about the introduction of this lesson. Earth was born about 4.5 billion years ago. Various formative processes have been taking place in the core of the Earth and its surrounding, and since its creation till today, these have resulted in the formation of various ores, liquids, and gases. Ore is a mineral, we can call it as type of minerals. Now, the substance around us are in the form of some of the other elements or in the form of the compounds. Some are in the atomic form, some are in the molecular form, some are in the compound form. In the beginning, elements were classified in accordance with the chemical and physical properties into the types metals, non-metals, and metalloids. And these are even these are the used even today also. You have studied their characteristics in the last standard. We are going to get more information about them in this lesson. Now, here, physical properties of metals and non-metals have been mentioned here. You just have to go through it once, though this part is deleted, but it can be asked in the form of objectives or in the form of additional questions or non-textual questions. It can be asked. So, just you have to read it once or you have to go through it. Now, we'll move ahead with the subtopic chemical properties of metals. Metals are very reactive. They lose electrons easily and become positively charged ions, and that is why metals are called electropositive. In case of metals, the outermost orbit contains either 1, 2, or 3 or 4 electrons, as a result of which they can easily donate the electrons, and as they donate the electrons to become stable, they acquire positive charge, and therefore it is called as electropositive. And since they are really in need to become stable, and therefore they are very reactive. The lesser the number of electrons in the outermost orbit, the more is the reactive, more are the metals to be reactive. Now, try this part is omitted from your syllabus this year. So we'll move ahead with the reactions of metals. Metal combines with oxygen on heating in air and metal oxides are formed. Sodium and potassium are very reactive metals. Sodium combines with oxygen in the air and even at a room temperature and forms sodium oxide. So, sodium is highly reactive metal who contains only one electron in the outermost orbit. So, when it is exposed to the air, it easily combines with the oxygen present in the air and forms sodium oxide. And it is represented by a chemical equation here. You can see that it is written as 4Na. Na implies sodium. It is in the solid form, reacts with oxygen in the air in the gaseous form, forms sodium oxide, that is again in the solid form. On exposure to the air, sodium readily catches fire, and therefore, to prevent accident in the laboratory or elsewhere, it is kept in kerosene. It is highly reactive and it catches fire, highly combustible also. If it comes in contact with the water or moisture, it will catch fire, and therefore, in order to avoid accidents, this sodium is kept inside the kerosene so that it will neither come in contact with air nor it will come in contact with water. Oxides of some metals are soluble in water. They react with water to form alkali. Now that example has been given here. For example, here magnesium reacts with oxygen to form magnesium oxide, and magnesium oxide reacts with water to form magnesium hydroxide, again which is an alkali. Now, reactions of metals with water. Now, here one experiment, small experiment is being done. The apparatus required as beaker, the chemicals required, samples of various metals. Important note: sodium metal should not be taken, and water. The reason I've already told why sodium should not be taken, because when it comes in contact with air, it forms sodium oxide, and when it comes in contact with water, it will catch fire. Procedure: take a piece of each of the metal in a separate beakers filled with cold water. Now, which metal reacts with water? Which metal floats on water? Why? Now, which metal reacts with water? Generally, those monoatomic, or you can say, sorry, not monoatomic, those atoms which is having one electron in the outermost orbit, they are highly reactive. They react with water very fast. For example, sodium and potassium, they react with water, but sodium has not to be taken because it catches fire. Now, which metal floats on water? Now, calcium reacts with water to form calcium hydroxide. Now, the calcium hydroxide, when the bubble reacts with it, bubbles are formed. So, bubbles, calcium gets stick to the bubbles, and bubbles come up on the surface, and therefore, to us, it appears that calcium is actually floating on the surface of the water. Though, actually, what it is, the calcium is attached to the bubbles, and therefore as bubbles comes up, even calcium also comes up, and it appears that calcium is floating on the surface of the water. Now sodium and potassium part is omitted, so we'll move to another paragraph. On the other hand, calcium reacts with water slowly and vigorously. Hydrogen gas released in the reaction collects on the surface of the metal in the form of bubbles, and metal floats on water. So I hope you have got the answer about which metal floats on the surface of the water, and why it is floating. That also I already explained. Now here calcium reacts with water to form calcium hydroxide, and hydrogen gas is given out. The metal aluminium, iron, and zinc do not react with cold or hot water, but they react with steam in the form of, to form their oxides. Hydrogen gas is released. So, in cold or hot water does not react, but in the form of steam, that is in the form of vapor, hot air, it reacts with these metals, and they form respective oxides, and hydrogen gas is given out. For example, aluminium reacts with steam to form aluminum oxide, hydrogen gas is given out. Iron reacts with steam to form iron oxide, and hydrogen gas is given out. Zinc reacts with steam to form zinc oxide, and hydrogen gas is given out. Now, how that experiment is being performed? So, this diagram is already being drawn here. So, with the help of this, you can take your metal sample is mentioned. Instead of metal sample, you can take any of these metals and you can perform the experiment. Test whether metals gold, silver, and copper react with water, and think worse. If it would have been reacting with water, the quality of the it would have formed metal oxide. But these metals are noble metals. They do not react with air or water in the atmosphere. And therefore, these are called as noble metals or rare metals. They are very costly. But silver reacts with hydrogen sulfide and turns black in color. And therefore, in the lab, silver has to be avoided in the laboratory. Now, reactions of metal with oxygen. In the earlier chapter, we have looked into the reaction of metals with acids. Are all the metals equally reactive? No. Depending upon number of electrons in the outermost orbit, the reactivity depends. So, when samples of aluminium, magnesium, iron, and zinc are treated with dilute sulfuric acid or hydrochloric acid or sulfate or chloride, salts of metals are formed. Hydrogen gas is liberated in this reaction. The reactivity of these metals can be indicated by the following. Here you can see most reactive metal is magnesium, then aluminium, then zinc, and then iron. So depending on that, your chemical reaction you can see here. Magnesium reacts with hydrochloric acid to form magnesium chloride, which is a salt, and hydrogen gas is given out. Aluminum reacts with hydrochloric acid to form aluminum chloride, which is a salt, and hydrogen gas is given out. Iron reacts with hydrochloric acid to form ferric chloride, again, which is a salt, and hydrogen gas is given out. Zinc reacts with hydrochloric acid to form zinc chloride, which is a salt, and hydrogen gas is given out. So all these metals are chemical reaction is similar, not exactly same, but similar depending upon the number of electrons in the outermost orbit. The reaction of metals with nitric acid. Nitrate salts are formed on reaction of metals with nitric acid. Various oxides of nitrogen like N2O, NO, and NO2 are also formed in accordance with the concentration of nitric acid. Copper reacts with nitric acid to form copper nitrate, nitrogen dioxide, and water is given out. If it is concentrated implies pure acid. Dilute implies water is mixed with the acid. So when copper reacts with dilute nitric acid to form copper nitrate, nitrogen oxide, and water is being given out. Here, additional information is given about aqua regia. Aqua regia is highly corrosive and fuming liquid. It is one of the few reagents which can dissolve the noble metals like gold and platinum. Aqua regia is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio 3 is to 1. Subtopic E in that practical part is not there or deleted from your experiment. So we'll directly move to reactivity series of metals. In the previous experiments, we have seen the reactivity of metals is not the same. However, the reagent oxygen, water, and acids are not useful to determine the relative reactivities of the metals, as all the metals do not react with them. The displacement reaction of metals with solutions of salts and other metals serves this purpose. If a metal A displaces another metal B from the solution and its salt, then it means that metal A is more reactive than the metal B. That is explained with the help of general equation. Metal A reacts with salt solution of metal B, and if A is displaced by B, we can say that A is more reactive than B. Then salt solution of metal A plus metal B is formed. In the previous activity, iron has displaced copper from the copper sulfate. It means that metallic iron is more reactive than the metallic copper. Now, scientists have developed reactivity series by doing many experiments of displacement reaction. The arrangement of metals in the increasing or decreasing order of reactivity is called as reactivity series of metals. Metals are divided into the following groups according to their reactivity. These are highly reactive metals, moderately reactive metals, and less reactive metals. Now, reaction of metals with nonmetals. Noble gases like helium, neon, argon, xenon, they do not participate in chemical reaction. Simple reason, because the outermost orbit is completely filled, and therefore they do not participate in any of the chemical reaction. So far we have seen the reactions of metals that cations are formed by oxidation of metals. If we look into the electronic configuration of some metals and non-metals, it will be seen that driving force behind the reaction is to attain electronic configuration in the nearest noble gas with a complete octet. Means the intention behind reacting is the intention of an element is that the element should attain the stability, that is in the outermost orbit either they should be, if it is first orbit it should be duplet or 2 electrons, or if it is second or third orbit it should be octet, that is 8 electrons should be there in the outermost orbit, so that they can become stable after donating or accepting the electrons, that is called as complete octet. Metals do this by losing electrons, with nonmetals do this by gaining electrons. The outermost shell of noble gases being complete, they are chemically inert. You have seen in the last standard that ionic compound sodium chloride is formed as sodium metal gives away one electron while non-metal chlorine takes up one electron, and thus a new compound is formed that is called as sodium chloride. This can be explained with the help of chemical equation 2Na plus Cl2. Metals and non-metals they react to form a salt, that is ionic compound sodium chloride. Similarly, magnesium, potassium form the ionic compounds called magnesium chloride and potassium chloride respectively. Now the chemical properties of non-metal is deleted from the syllabus. First paragraph is deleted. The reactions of nonmetals with the oxygen. Generally, nonmetals combine with oxygen to form acidic oxides. In some cases, neutral oxides are also formed. That is being explained with the help of the reaction. You can see here, carbon reacts with oxygen to form carbon dioxide, that is called acidic. Carbon reacts with oxygen to form carbon monoxide, which is neutral, and sulfur reacts with oxygen to form sulfur dioxide, which is again acidic in nature. Reactions of nonmetals with water. Generally, nonmetals do not react with water except the halogens. For example, chlorine on dissolving in water gives the following reaction. Chlorine reacts with water to form HOCl plus hydrogen chloride. The reaction with dilute acids with nonmetals. Generally, nonmetals do not react with dilute acids. Halogens are exception for this. For example, chlorine reacts with dilute hydrobromic acid by the following reaction. Chlorine reacts with hydrogen bromide to form hydrogen chloride, and bromine is given out in the molecular form in the aqueous form, that is in the presence of water. Reactions of nonmetals with the hydrogen. Nonmetals react with hydrogen under certain conditions such as proper temperature, pressure, use of catalyst, etc. In the reaction between chlorine and hydrogen bromide, a transformation of hydrogen bromide to bromide takes place. Now, can this be called as oxidation? Which is the oxidation that bring about? So, about the oxidation and reduction, we'll be dealing it in the next video. Till then, have a great day. Remaining part we'll discuss it in the next video.